Okay, for this lesson, we are learning about volume of a pyramid. Volume is what's poured inside. If this was a lid that we could pop open for a minute and fill it up, it would be how much goes inside. So the previous lesson was surface area, where we were just measuring the outsides and adding them all up. Now we're measuring how much would fill the inside. So think of it as a liquid that's being poured inside and filling it up. So we are going to take, and actually, the reason this is actually the picture here is because if you took a cube with the same height as these three pyramids and filled it up with some type of a liquid, it would pour into three of these containers, because the volume of a cube is length times width times height, and the volume of a pyramid is length times width times height, but then divided by 3. So they go to a point which divides it into thirds, which is why this cube is shown filling up 3 different pyramids, because it is each 1/3 of what would have been the entire cube's volume. So the general formula for the volume of a pyramid is for volume equals, you would do base times height divided by 3. Now, I want you to notice that this B is capitalized. That means it depends on what type of base it is. In this picture, the base is a square, so your base would be length times width to get the base. So it's length times width, and then times height, and then divided by 3. But when the base is not a square, when the base might be down here, for example, a triangle, then it wouldn't be length times width times height. It would be length times width divided by 2 times height, and then divide the whole thing by 3 because it goes to a point. So what will be the exact formula for a rectangular pyramid? So I'm going to break down this capital B into length and width. So for a rectangular pyramid, you will take length times width and then times height, and then divided by 3. So this is the same formula as this, but my base of a square is length times width. Times height is still the same, divided by 3 is still the same. Okay, so then when you're talking about a triangular base, it's not just length times width in a triangle. It's length times width divided by 2. Then once you take that, you multiply by the height, and then you take the whole thing and divide by 3. Okay, so this is a bigger formula, but I want you to just think of this as your just capital B. So your base is whatever the base is. If it's a rectangle, it's length times width. If it's a triangle, it's length times width divided by 2. Or base times height. Sometimes you call it base times height, sometimes you call it length times width. It's the same thing. So let's go down here and look at example A. This is a pyramid actually in Egypt. I think it's the Great Pyramid of Giza. So it's a massive structure. To find the dimensions in meters, we're going to calculate the volume. So this is a square base. They've actually drawn it better, a little bit of a better picture of it right here. It is a 440 meter square base. And the other side of the line is not marked, but that's because we know it is a square pyramid. So we're going to do length times width. So that is a 440 by 440. So we're going to take, there we go. So we are going to take 440 times 440, because that's length times width, times height, which let's see how tall this is. This height needs to go from the center straight up to the top. It's not on the slant. The slant is kind of just excess information. We don't need that unless we were doing surface area, which we're not. We need the height in the inside invisible line from the center straight up to the top. So that is 280. So that's our height. And then we're going to take that whole thing and divide by 3. So in your calculator, 440 times 440 times 280 equals, divided by 3 equals. So it is really, really big. It doesn't say round to the nearest anything, so I am going to have you guys just round to the nearest, let's just say whole number. So we're not going to do the 0.33 at the end. So this is just going to be 18 million. Okay, so let's put this down here. 18 million 69,333. And volume, and they said meters, volume is always cubic meters, so it's to the third power. So it's to the third because it's 3D. So I don't know if that helps you make sense. It's what's filled on the inside three-dimensionally. So it's cubic. Okay, turn it over and we are going to look at some earrings. So these are triangle bases. So we're going to have a triangular base. And what the question says, let me read it, is Joey wants to make his wife brass earrings like the ones pictured for her birthday. In order to make them, he needs to know how much brass to buy, and it's by volume. So we first need to come up with the base, and the base is a 2 by 1.75, and since it's a triangle, we'll divide by 2. So let's just do the base. The base again is 2 times 1.75, and since it's a triangle, we will be dividing by 2. So let's get just that part first. 2 times 1.75 equals, divided by 2 equals, wait, I want to make sure I just did that right. Oh yeah, times 2 divided by 2, 1.75. Okay, that is just the base of this triangle. So remember, in order to find volume, it's base times height divided by 3, and we just did the base. The base is 1.75. The height is from the center of the triangle straight up. That is the 1.5. So we're going to take 1.75 times 1.5 and then divide by 3 to get the volume of one of these earrings. So 1.75 times 1.5 divided by 3, 0.875. So this equals 0.875, and that is centimeters cubed. However, that's only one earring, and so I think he's going to need to buy a pair, a matching pair. So we're going to take 0.875 and multiply by 2 because there are 2 earrings. And that would be 1.75. So that's how much brass, that's how many cubic centimeters of brass he is going to need to order. Okay, the next question, let me read it to you while you look at this picture. It says Curtis builds a doghouse with a base shaped like a cube and a roof shaped like a pyramid. The cube has an edge length of 3.5. I'm going to make that 3.5. Same thing as 3.5 feet. The height of just the pyramid, so just from in here, the height of the pyramid is 5 feet. Okay, we already know the height of this is 3.5 because by definition of a cube is the same on all sides. So we have 3.5 here, 3.5 here, and the height is also going to be 3.5. But the height of the pyramid is 5, and that is going to come in handy here in a minute. So we need to find the volume. Here's what I'm going to suggest. Let's find the volume of just the cube first, and then we'll find the volume of just the pyramid, and then we'll add them together. So let's not even look at the pyramid for right now. Let's just find the volume of the cube. Cubes are length times width times height. So we're just going to do 3.5 times 3.5 times 3.5. Okay, we're going to multiply all of these. So 3.5 times 3.5 times 3.5. Oops, sorry. And that equals 42.875. So 42.875, that is just the cube. All right, now let's forget about the cube and let's look at the pyramid. So pyramid's volume is length times width times height divided by 3. Now, how do we know our length and width? You should already know because it's stacked really nicely just right on top of this 3.5 by 3.5 cube. So this is going to be 3.5 and this is also going to be 3.5. So we are going to take our dimensions and do 3.5 times 3.5 times the height, which is 5, divided by 3. So 3.5 times 3.5 times 5. Let's go ahead and multiply all those together, and then we'll divide by 3. Okay, 3.5 times 3.5 times 5 divided by 3 equals 20.41 We'll call that 7 for now. 20.417. 20, oh, I already did that math. 20.417. Okay, now that we have the pyramid and the cube, we are going to add them together. So I'm going to find some space over here, and I'm going to add 20.417 and 42.875. And we are going to add them together for the grand total 20.417 plus 42.875 equals 63.292. 63.292. Now, it wanted us to actually round it to the nearest tenth, so that is this number. So the 9 will bump this number up to a 3. So our rounded total will be 63.3 cubic feet, since we're talking about volume. All right, our last example is the Louvre. It's a famous museum in Paris that houses a lot of famous artwork. So there are 2 apparently glass pyramids at the Louvre. The outdoor pyramid, which has a square base and side lengths of 35.4 and a height of 21.6. And then there's an indoor pyramid, and it's a little bit smaller. It has side lengths of 15.5 and a height of 7. So how many times greater is the volume of the outdoor one than in the indoor one? So let's just do these one at a time. Let's figure out the outdoor volume. The outdoor volume is a square base. It says it is a square base. So it's going to be 35.4 by 35.4, because that's what a square base is. 35.4 on one side, 35.4 on the other side. Okay, so we're going to do 35.4 times 35.4 times the height. What did it say the height of the outdoor one is? 21.6. And then we're going to divide the whole thing by 3, because that's what a pyramid does. All right, let's do that. So 35.4 times 35.4 times 21.6 equals, divided by 3 equals. Let's just put it all for now, 9,022. So this is 9,022.752. Okay, this is the outdoor volume. Okay, let's find the indoor volume now. Indoor is also a square base, so it has side lengths of 15.5. So that is going to be 15.5 times 15.5 times the height. It tells us the height is 7 meters. And then the whole thing divided by 3. So let's put that in our calculator. 15.5 times 15.5 times the height, which was 7, equals, divided by 3, equals 560 point, we'll call it 583. Okay, now that's not what the question was. We didn't need the outdoor volume and the indoor volume. We wanted to know how many times as great. So if it says how many times, what they're asking is how many times can we multiply this number and it become this number. So if you're working backwards, a really good way to see how many times this goes into this is to divide it. So we're going to take the bigger number and we're going to divide by the smaller number to see about how many times. So here we go. 9022.752 divided by 560.583. It is a little bit over 16, but I think it says about how many times, so we're going to say about 16 times. This is rounded, but we'll say it is about 16 times greater. All right, there you go.